Hello, everybody. So this is explaining the step two. Um, Now the task here, the assignment says, recollecting what we did last week. So recollect, we explained static determinacy. It needs to be 2j equals to n plus r, and that for equilibrium, all positive moments must equal all negative moments. So that means when you total everything, it should equal to zero. And then we also saw that summation of all forces on the x-axis will be equal to zero, and the summation of x-axis and y-axis should be equal to zero. All right, so the task item number 2 said copy and watch the video. I hope you will do that. It says as a refresher of what we did last week. When you open the video on this link here, you want to rewind and just watch the first 7 minutes. That's like reminding you of what we did last week. And then when you watch from 12.30 minutes to 16.30 minutes, it explains what we're going to do right now. Okay. So explaining steps 2-1. All right. So I uploaded some documents. The first one, explaining steps 2, number 1. The number 1 document, which is this one here. It's basically saying that, remember from last week, right? Beginning of step 1, for forces in equilibrium. The other equations which we've not used so far, like I said before, summation of axis on the forces on the x-axis will be equal to 0, and then summation of forces on the y-axis will be equal to 0. Okay, so that's that. And then the next thing to note will be in the example. So I will not. It's your job to do the assignment. So I will use the example again. So here, in the example I gave, which was what you drew on MD solids, so we had determined from our calculations that this here, we determine FCY, we determined that to be 400 from our calculations, right? And so the force here, which is acting upwards, so it's going to be a positive. Forces acting upwards are positive, like in your graph for x and y. Anything above the central line is positive. Anything going down from the central line is negative, right? So calculating for things on the x-axis. Now I think we do the y-axis first, right? So on the y-axis, we determine that this FCY, which is on the y-axis acting up and down, right? So this tends to be going up, so it is positive, while the 800 is coming down, so that's negative, right? All right. So here, let's go back to the x-axis. Okay, so for the x-axis, right? Now, because there's only one force acting in the direction of the x-axis, that's this one here, FAX. So the total of the forces on the x-axis must equal 0. So if it's only that FAX, then FAX must equal to 0. Then now on the y-axis. Okay, so on the y-axis, FCY will determine to be 400, right? So positive 400 minus 800 plus FAY is going to be equal to 0. That's what's written here. FAY, this one, which is acting upwards, so it's positive on the y-axis, minus 800, which is acting downwards, plus FCY, which is acting upwards, is equal to 0. So we know this FCY to be 400 already from last week. Okay, so forces pointing up are positive, while those pointing downwards are negative, it said. Okay, so when we add 800 to both sides to get rid of this 800 from the equation, right? So we do plus 800 here, plus 800 there. That gives us, this cancels out, minus 800 plus 800 cancels out. So FAY, which we are trying to determine, because we know FCY already. So FAY plus FCY is equals to 800. Okay. So we already know that FCY is that, and that's because we already know that FCY from last week. FCY, this one here, is 400. Okay. So FAY plus 400 is equals to 800, and from that, when we subtract 400 from both sides, FAY is going to be equals to 400. That's the answer for FAY. So this is 400 and that's 400. All right. So from step one, we calculated FCY to be 400 pounds. If FAY plus 400 is equals to 800, subtracting 400 and 400 from both sides of the equation, then FAY is equals to 800 minus 400, right? Which is equals to 400. All right. So that's the 400 pounds. Okay. So now the task you guys are supposed to do is the next one here. So that's the task you had, okay? We had determined, some of you that turned in last week's assignment calculated this one already, okay? Now it's important to show me the steps, how you calculated it. That's what you get points for, not just writing the answer, because you can copy the answer I wrote down there, okay? All right, so make sure you show me the answer, the calculations, okay? So remember, this is a pinned joint, and this is a roller joint, okay? So that means this joint is not acted upon. It can expand this way, basically. It can expand this way, so there's nothing stopping it. But there's a force stopping it from moving in this direction. That's the force here. There's also a force acting on it this way, which is the resistant force for the total, for all the load acting on it. It's part of the resistant force, okay? Now you have a force going down for 300 pounds, another force coming down here for 700 pounds. The first step of the problem was to calculate using moments, which is calculating forces times distance, right? Okay, and this is your 0 point here. So you measure your distance from the 0 point when you calculate, okay? So now the step two, now for step one, you need to go back to the notes for last week, the step one of the problem, to read the notes and follow the steps. So for the step two, you're meant to calculate using summation of forces, like we said, equation 2 and equation 3. Summation of forces on the x-axis, summation of forces on the y-axis. Okay, so remember, total of all forces acting on the x-axis must equal to 0. Total of all forces acting on the y-axis must equal to 0 as well. So good luck. Show me your work, turn it in, make your notes so you get full points, okay? And you get all available points for notebook entries and for solving the problem. Okay, hope you're still staying safe. Thank you so much. Bye-bye.